Happy day to you. Welcome to Math for All, where everyone can learn more about math. I'm Denise, and together we are embarking on a topic called systems of equations. Thankfully, this video is an introduction in case you're not even sure what that means. We will answer the question of what are systems of equations? Well, let's back up first. You should be comfortable with an equation that looks like this. Y equals 5x minus 2. Do you remember the solution to him? It's a straight line with infinite answers because as the x changes, so does the y in a very nice, neat pattern. He is not a system of equations until we incorporate another equation into the mix, like y equals 5x minus 2 and y equals negative 3x plus 6, usually connected by the set symbol to show that they are connected to each other. It means that we need to find the x and the y that work in both of these equations. If I had to use words to define a system of equations, I would say that they are when more than one equation governs more than one variable. You will learn how to solve systems of equations by using at least 3 different methods: graphing, substitution, and elimination. But first, we'll tell the math question people which point is a solution to the system, like this one. Which of these points are a solution to the system y equals 5x minus 2 and y equals negative 3x plus 6? Is it 0, 6, 4, 18, or 1, 3? To answer this question, we have to plop each of these xy buddies into both equations and find the one that makes both of them true. It looks like this. To check if 0, 6 is a solution, we put the x and y into the first equation, y equals 5x minus 2, turn the y into a 6, and turn the x into a 0, for 6 equals 5 times 0 minus 2. You should get into the habit of putting the question mark above the equal sign when we don't know if both sides really equal each other. But 6 does not equal negative 2, so it cannot be a solution to the system. We could show it works for the other equation, but there's no need to do that extra work. Next, trying 4, 18, we put it into y equals 5x minus 2, for 18 equals 5 times 4 minus 2. 5 times 4 equals 20. Does 18 equal 20 minus 2? Yes. That's great news, but it also means we must check the other equation of y equals negative 3x plus 6. 18 equals negative 3 times 4 plus 6. Negative 3 times 4 equals negative 12. Does 18 equal negative 12 plus 6? Nope. 18 does not equal negative 6. Bummer. It means we're not done yet. Our last point and probable winner is 1, 3. Does 3 equal 5 times 1 minus 2? 3 does equal 5 minus 2. Yes, so that's great. Then the other equation. Does 3 equal negative 3 times 1 plus 6? 3 does equal negative 3 plus 6. Yes, so the solution to this system is the point 1, 3. Great job. Now that we know what systems are and how to find which point is the solution, we'll learn the first method in solving these, graphing. We take each line equation, graph them on the same coordinate plane, and find their point of intersection. So, if we have to find the solution to y equals 4/3 x minus 2 and y equals 2x, we plot them carefully on graph paper. We could also use a grapher either online or on a graphing calculator, but call me old school, but don't call me old. We need to know how to graph these with paper. Start with our favorite. I'll just do the first one, y equals 4/3 x minus 2. Do you remember y equals mx plus b? Plot the -2 first on the y-axis. From there, it's up 4 and over 3. Straight line between those points, awesome. Next is y equals 2x. His y-intercept is the invisible 0 here. The slope is up 2 over 1 and you put a dot there. Line, and then where do they meet? Back here where x equals -3. But we have to give the full point of -3 comma -6. If I put that x and y into both of the equations, they will work out perfectly. The graphs are pretty fun, but they're limited by our neatness and our straight lines, and if they don't meet at nice integers, we can only estimate their decimal point. We can't really find 4.175 on a drawn graph. But don't fear. Our next two methods will give us exact answers using algebra skills. So keep watching videos to continue your math journey.